It's good to be back. So today, Etienne and I are going to talk about gaining actionable cross-project built insights. But first, a few words about ourselves. I'm Laurent. I've been in continuous integration for more than 20 years, and then understanding productivity. I worked in the financial industry and at Spotify, and I made all the mistakes you can think of in CI/CD and measuring productivity.
Hi, my name is Etienne. I'm the SVP of Engineering of the Develocity team and co-founder of Develocity.
So let me start with data-informed development, some use cases. Last year on this stage, I introduced you with this mental framework. At the top is knowledge. We want to understand the world we live in. We want to know how the organization works. But most importantly, we want actionable insights, what we should fix, maybe some suggestion on how to fix things. If we have compromised elements in a toolchain or in infrastructure, what should we do next? What is the most impactful change we can make to the infrastructure? In order to do that, of course, we need information, metrics, charts, dashboards, etc. And of course, first, we need data. But whenever I present that, I get a lot of feedback and questions. The first question is, how do we start such a journey? How do we create value step by step and justify the investments? So today I will present a few use cases that illustrate how to build a data-informed company. First, we're going to look into what are the actionable insights we want, some metrics and dashboards, and of course, what data we should collect. All right, so let's start with CI failures. We all know that failing tests are a real pain. They can be flaky or they can fail for good reasons. But how do you approach the problem? So I was in charge of a pretty large CI environment where developers complained a lot about the failures. They were right, of course. So we needed to improve the situation. But let's take one step back first. We need to understand, did the problem come from the test? Did it come from the test frameworks? Did it come from the product itself that might be flaky? Or does that come from the infrastructure? So one of the key aspects of solving a problem is to make sure that the problem is assigned to the right person. It makes no sense to have a CI infrastructure team solve product issues, and it makes no sense to have a development team solve infrastructure problems. The pain needs to be where the pain belongs. So we realized we needed to categorize the test failures by sort of root cause. So we collected all test results and we automated categorization over that. 1/3 was obvious, it came from infrastructure. 1/3 was very obvious, it came from development product issues. And 1/3 we just didn't know. And guess what? Nobody wanted to take care of those ones. Anyway, we could then ask the right person to fix the right problems. The key here was that we needed to collect all the test failures and then we could categorize them. The transparency with regard to the source of the failure created clarity in the entire company. And we could focus the infrastructure team on the most common infrastructure issues. We could help identify some failures or flakiness issues in the product. And we could fix some test frameworks, which did have problems as well. Anyway, we could reach out also to the teams that had flaky tests and ask them to fix them. It justifies the investment and it paid off pretty well. In this case, we needed test result observability. So again, what to fix, by which team, how to categorize, and the data we needed, test results. Now, another use case, a very interesting one. Let's say you have a pretty slow CI environment where you have long queues. Here's what happened. We had long queues in CI. So of course, what did we do? Well, we actually doubled the speed of the CI machine by investing a lot in much faster machines. Of course, initially the queues disappeared. And then we waited another 2 weeks. And then we got longer queues than before with faster machines. So we waited a bit more and seriously, what the hell? That's what happened. So how to solve such a problem? Well, it is unintended consequences. But how do you understand what happens? And why do queues get so much longer with faster machines? The key was to be able to capture all the data from the local builds and the CI builds and to analyze what happened. So we collected data from the CI builds, from the local builds. And as you probably know, collecting data from CI builds is feasible. Collecting a lot of data from local builds is a lot harder. Because there's also so many ways for queues to appear in CI. It can be that you run too many tests, that you don't parallelize them, that you maybe you have linters that take too much time, or you have too high-level tests. Many things can happen. In this case, we really wanted to understand what happened on developers' machines. And what we saw is the following. We could see there were more CI builds and actually fewer local builds for developers. And then we go talk to them and realize that actually developers realized that the CI machine was so much faster that they stopped running their builds locally and they threw them at the CI machines in a cloud, because why not? What is important here is that we needed local and CI build observability. Now, next thing is, you probably know that in a multi-repo world, things are very simple, right? You have many apps, you have dependencies. For many good reasons, you want to keep the dependencies up to date, because it could be CVEs, it could be communication between apps that need to have the same libraries, and so on and so forth. In reality, that's more like that, right? V1, V2, V3, etc. That's different. And of course, that can be even more complicated. This one is compiled with JDK 7, this one with JDK 8, this one with JDK 20, you name it. So what did we do? We collected all the information about all the dependencies, and then we look at typically one of the dependency and look how old, which version was actually used by the app. And then you realize that most of the apps have a pretty decent or pretty recent dependency. That's the green ones. But a decent number of apps have very old dependency for the same dependency. There can be many reasons for that, because maybe the app is not taken care of anymore, because it's not prioritized, or because there are so many apps, so many dependencies to update that people just don't do it. In order to see that, you need to have a complete observability of all your dependencies. In this case, this is which dependency do we need to update, where, and potentially where to update the build platform. I'm talking about JDK, but it could be a linter or any sort of other tool. And of course, the information you need for that is all the apps, all the dependencies, all the apps, all the toolchain elements, such as, again, JDK, linter, and etc. And for that, you need some raw data, which is source code, build configuration, build log, SBOM, etc., etc. And now let's talk about the fourth case. Many repos to optimize. So in a typical company, if it's large enough, you're going to have a few very large repositories, which are used a lot with a lot of activity, and maybe a lot of smaller ones. The thing is, optimizing by 30 minutes for 2 repos that have a lot of builds saves the same amount of time than if you optimize the same thing on 2,000 repositories with only 10 builds a day. But we tend to focus on the bigger ones because it's visible, it's high impact, we have happy users, it pays off. Numbers look good. But I led a CI team with many, many repositories. So what if it was much easier to pinpoint the problems everywhere, get suggestion on what to fix? And what if we could easily notify people that they can do a small change that's going to have a big impact? So now what you need here is a project observability. All in all, this, for example, I gave you, the key point is we need toolchain observability across all projects, because this data will enable you to make big optimization. And with that, over to Etienne.
Thank you, Laurent.
One more.
All right. So the developer toolchain, as you surely agree, has an important impact on developer productivity. Right? So it is essential that we capture comprehensive data about what happens in your build in order to make informed decisions about what to keep, what to improve, and the expected outcomes you can expect. And I'd like to take you a little bit on a journey on how we in Develocity, in our product, approach observability. It will be a bit technical, but I will also end up with some real use cases. So in order to have this comprehensive data available about which you can reason, we provide a set of plugins for different build tools that eavesdrop what happens while the build is running. So they don't look at your POM XML, and they don't look at your build.gradle or any other build tools files. They listen to what happens while the build is running. And like it was said in the keynote yesterday, the ultimate truth is what happens while the build is running. You can apply those plugins directly in your build, in the repository, check it in, or you can also inject them from the outside, typically via a CI plugin that you run on CI. If you do it on the repo, the benefit is you also get local builds. And that's typically a big black box. If you don't instrument your builds directly, you will not know what's happening locally. And if you cannot don't know what's happening. You cannot reason about it. You cannot make an improvement for all the developers building on their machines. On the other hand, if you use the injection from the outside, typically on CI, the benefit is, even though you don't get local builds, you don't have to touch the build. You can just inject it and it's not modified. But ultimately, in both cases, the build is instrumented and listens to what happens while it is running. So a lot of interesting things happen while the build's running. And what we do is we capture this in the formation in the form of very little events. They're very specific, they're extensible, they're backward compatible, and they capture a little piece of information, and this is spooled to disk while the build is running. So you have hundreds, thousands, sometimes hundreds of thousands, if not millions of events that happen depending on the size of a build and what the build does. So at the end of the build, everything's spooled to disk. We upload that data to the server. This is how we initially did it, and you can still do it like that. That is, all these spooled events are sent to the server as one big blob, and they're persisted in the database. Right? So the data comes in, is persisted in the data, is persisted in a Postgres database, and then asynchronously, it is loaded again, and the events are extracted and mapped to database tables. So all events go in a table, but because that would lead to quite an explosion of events, and typically not that much changes between events, we deduplicate these events. So if you have twice the same event data happening, so the same task started with the same name, etc., the same path, we only store it once, and we have another table where we then just reference it. This duplication is highly successful, and we have a really, really high deduplication rate because of that. Then we have another table that kind of represents the build. So each build consists of a number of events, and each event references the actual event data. That works well, but it has some scalability issues if you have a really high amount of builds with a high amount of events generated as part of these builds. Postgres scales really well, but you might have an amount of builds where it gets to its limit. Also what cloud providers offer, and what you're willing to invest to make Postgres scale more and more. Also, S3 as a storage became more and more popular over time since we started Develocity. And so we provide an alternative way where the data, as it comes in as a big blob, is streamed directly to S3. And there it stays. It's not further processed and events extracted. It just stays there. S3 pretty much scales infinitely. It's also very cheap in terms of storage costs, cheaper than if you're using an external Postgres database from a cloud provider. So these are the two options you have available. You can also use them together. You can say, I'll start with one, and if we ever hit some ceiling, we change to the S3 approach, and you still have data in both locations, but they can be read. There's no difference. You will not notice this as a user. Once you have that data persisted, you want to do something with it, right? You want to look at what happened in that build. You want to reason about it. You want to make decisions based on it. You want to collaborate it, find root cause failures, and so on. And that's what we visualize in the so-called build scan. Right? So it's the visualization of a persisted build record. And there I just give you some examples. For example, you have very comprehensive data about failures. And I think everybody has build failures. Right, so this should be highly interesting to see everything down to a stack trace. Or you might have multiple failures in the same build. They're also available here. Another example, tests. Most people run tests. But how many did you run? Which ones took the longest? How much did the test setup method take? Which ones failed? Which ones are flaky? All this information is captured as in that build information in these events and is visualized here. And as a last example, dependencies, very, very, pretty sophisticated in many build tools, especially in Gradle. So there is a lot to capture, but there's also a lot to visualize here, like which configuration resolved which dependencies, also third-party dependencies, where did you have conflict resolution, what is the reason why a certain version was used over another version. All this is available because it's captured in the data. And that's really what I'd like to emphasize here is the comprehensiveness of the data. Once you have that data, you can you can work with it, right? And one way is to visualize it and then take actions based on that. But not always is it good enough to look at one build scan. Oftentimes you want to reason about things where you need to have a bigger window of time during which many builds happened. And for that, we have built very specific views on topics that we know everybody needs. Everybody has tests, everybody has flaky tests, everybody has failing tests. So we provide specific views for that. For failures and so on, the same thing. So what would not work though is, as you remember from before, if we store those builds, for example, as blobs in S3, if we now want to do a query across many builds and we have to go into each blob and extract whether they match, that would not scale across millions of builds. So what we do is we take in the background, with the background process, we take those blobs, whether they are in S3 or they are stored as events in the database, doesn't make a difference, but we project them to specific tables that are backing a view that shows data across many builds. All right, so these are these projection tables. And once we have these tables in place, we can query them very fast, and we can also aggregate the data and display the data very quickly. Some examples here, if you want to see information about your flaky tests for a given project, just on CI, you can do the filtering. The filtering works against that projection table. The remaining data that fits is then aggregated, sent to the UI and displayed. Or you want to know how much could I save from predictive test selection. Same thing, there's a backing table that is queried, that gets the data is extracted, processed, and visualized. And as the last example, failures, you want to know what are the most common non-verification failures on local builds. Who could answer that question today for their project? Okay, so nobody. So nobody could say, oh, these are the most common non-verification failures people have on their laptops. Or people are just too tired to raise their hands. But in any case, we can answer that question here. But we need to go across many builds, and for that we have a projection table in place. But there are many more questions you could ask, and you want to ask, right? Beyond what we can offer out of the box. Some people have lines of businesses. Some want to group things by repositories, others by project, or whatever dimension you have, right? We cannot anticipate all these different dimensions. And so either the product will become like a generic BI tool, data retrieval and data visualization, or we just give you an easy way as a customer to ask the questions that you want to ask. So the way we started this was quite some time ago, but it's still available, it's still there. We have an API where you can get out all the events. This is just a few events out of, as I said, thousands or even hundreds of thousands of events you would get for a single build. This is exactly what we persist. If you take this information, you know as much as the Develocity server knows. But the downside is, of course, you have to do it all yourself. You have to take these events, you have to process them, you have to aggregate them to something higher level. And this is not always easy. Sure, if it's task started, task end, you calculate the difference in the timestamp and you know how long that task took. But there are more complicated things like, oh, how much avoidance savings am I getting because that was taken from the cache? That is more complicated to calculate. So this is an API there. It's very low level. You can do what Develocity can do with this data, but you have to do it all yourself. It's based on server-side events, server-sent events. It also means it supports pushing. So every time a build comes in, you can be informed and react to it. Okay. So, and also you need to write your own client, right? The client needs to be resilient to failures. It needs to pick up work where it stopped when new builds come in and you stop the client. You need to persist that data probably in some format and so on. So pretty involved. We basically say, hey, you do all the work. Then we decided we want to make it a bit more convenient. We'll provide you some higher level build models that provide a specific view on certain aspects of the data. This is again just a small extract, but you can already see this is easier to consume. Right? You see some information about custom tags, you see some information about build options, and you would see the same for tasks and build cache performance and so on. But you still have to write the client. It still has to be resilient to failures and so on. That's still all your work to do. These build models, we have multiple of those, and I just listed a few of those of the things you can get out. So consumption is easy once you have a client, but that part you still need to do. And of course, if you have a lot of builds, you need to build a system where you get that data out, and then you can query it in a performant way. So you also need to solve that problem. And depending on where you are, that problem is already solved in general. For many companies, it is not. Okay. So we wanted to go further and give you a way where you can instantly ask the questions you want to ask about the data and not worry about any technical setup, any technical challenges you have to address first. And the approach we chose here is that you have to keep in mind we have an on-premise product with Develocity, is that we would still leverage cloud provider services because many of our customers run the product in the cloud. And so what we went for first, because many of our customers are in AWS, but it applies similarly to the Google Cloud and Azure, is that regardless of where the data is stored, in the database or in S3, the actual events, we apply the same projection mechanism that I mentioned before, but instead of writing it through a projection table, I mean, we still do this for what I showed before, but in this case, we also run one of these projection mechanisms to store these build models that I just showed and store them in a compressed JSON format in S3. So for each build, all the build models, and I listed a few just a second ago, are put into one file that is compressed, and that file represents then that build and is stored in S3 here. Why exactly this format? It's a format that is very easily consumable by Athena. Athena is a big query engine, and it can very well read that format. We also put that data into different folders. Each folder is for 1 day, because typically when you query data, you will give it a time range. And if the folders are also time-based, so to speak, it becomes easy for Athena to consume and pick the right folders, pick the right builds in there. We also need glue for the schema definition of those JSON models, but that is kind of a side effect. So, and then you can query Athena. There's an Athena console. You can ask any questions you want to in SQL. All right, so the learning curve there is pretty small, assuming you know SQL to some degree. But there are some, and this works really well. We have many customers using that in production successfully, but there are some rough edges here. For example, if you have a lot of builds, and I mean really a lot, right? Hundreds of thousands per day, that means you have a lot of builds in each folder. And now you hit some rate limits on AWS. Because if all those compute nodes of Athena take a piece of the work and they now query the data, you have a lot of queries happening at the same time. And it goes beyond the limit that AWS provides. It's also not configurable. It's not changeable. So you hit some rate limits there. But unless you're at the high limit of upper ceiling of how many builds you create, you're not going to face that. Another one is this JSON format, even though it's compressed, it's not the most efficient in terms of storage. And with Athena, you pay by how much data is read. So if there's more data to read, even though it doesn't contain more information, you pay more. And there's also a penalty you pay in performance, even though it performs well, right? But there's still a penalty compared to what I'm going to show you in a second. And that is because every build is represented by a single file. You have a lot of files, and they need to be distributed to the different compute nodes. That creates a lot of traffic. That comes with latency and a decrease in performance. So that is version 1. It works in production, but we can do better, and we want to do better. And so what we are about to release now is that things are still stored in the compressed JSON format, as I mentioned before. But instead of directly consuming this from Athena here, we are feeding these JSON files to Athena and tell it to convert them to an ORC format. So it's a different representation of the same data. It's more optimized for heavy reading of data. And also, while that happens, we can give it multiple build files at once, and they're going to be stored in one ORC files. So we end up with less ORC files than initial JSON-based build files. That means less to distribute to the compute nodes as well. Okay, and so as a result, better compaction means you pay less because there's less to read, less to transfer, less data to transfer, but also less files to transfer. You get all these gains that add up in terms of performance that you can expect when you query the data from Athena. So to summarize this part, so using ORC to store the build data, you can query faster, and we have some preliminary benchmarking. It's not the final one. It's about factor 10. And with disk space, we see about 90 to 95% reduction in size. So it's pretty dramatic. It doesn't mean what's currently there is like wasting and slow, but this is of course much better. Also, we don't hit the rate limits anymore, or you as a customer wouldn't hit them anymore, because there are not that many individual file reads that need to happen against S3. Now we did a third optimization that has nothing to do with what I showed here, but I think it's still interesting. So when you have JSON data with arrays, in order to make them queryable with Athena, they need to be unnested into multiple rows. And that process is expensive in terms of its slow. So when you query that data that has arrays in there in JSON, it becomes slow. And so ideally you would have materialized views, and then you only pay the price once and then everything's fine. But they don't exist in Athena. So we decided we would write them to actual tables. So as part of the process of taking a build, feeding it to Athena, we're also adding the build to an actual table. And there it does this on-nest operation. You pay the price once at the right time, and then when you read it, it's already optimized and it's fast. Also has a very significant effect. We haven't tested this in isolation in terms of performance improvement, but we already know roughly that it's quite significant. So we'll do this more thoroughly very soon. All right. So you can query Athena with or the data via Athena console, right? But this is still maybe not where you want to start, right? Many people have the same questions about their data. And we know that from interacting a lot with customers. And so we provided a set of pre-built Grafana dashboard definitions that you can integrate in your Grafana environment, or you spin up a new instance, or use Grafana Cloud, however you choose, or even the AWS, they have a service there. And it comes with like 25 or so dashboards that try to surface actionable, insightful data. Right? The goal is not to just have dashboards, here's some data, but it's really surfacing things you can do something about it. Some of them show charts, like here. Some of them show trends over time, and some show actual tables. You don't have to read it, but you have to just recognize that it's a table. These tables you can also export in CSV format. I mean, that is just basic Grafana, right? But then you can further process it in another tool if you even wanted to. What is quite interesting though, even without exporting, you can do different types of sorting. You might say, I'm most worried about for example, the failure rate. Others might say, I'm most worried about those projects where I have in some the most build time on builds that actually fail. You might have different criteria that you're interested in, right? And depending on how you group the data, maybe by project, or even better by group project and the invocation of a specific task or goal, you can identify those projects that you want to follow up further. So dashboards we have are for different areas, like I said, and every release has more dashboards. And of course, each dashboard, because it is based on these build models, we also add more build models. So if you want to consume that information with a different visualization tool or other reporting tool, you can do that as well. A question that often comes up is, what about alerts? Right? People want to send out alerts on certain state of their tool chain. What those are is a discussion on its own, and you can define your own, of course. But for example, if you're on an AWS, you can set up an event batch scheduler that just invokes a Lambda function every 5 minutes, every hour, whatever it is you want to search for. That Lambda function invokes Athena. You get the data you're interested in. You decide based on the result whether you want to send a notification or not. If you want to send one, you can use a notification service, send an email, or whatever that notification service has been configured with. So that is very easily possible. You can also use Grafana alerting already built in. Then you don't even have to go on the level of AWS. But very likely you have your own notification service already, right? But still, the question comes up quite regularly. Now you might say, oh, but I'm not in AWS, so this doesn't apply to me. But you can still get the insights and do the data exploration and everything that I showed before. Because what we also have is a reporting kit. And that reporting kit ships everything in one bundle. It's an app. You install it like Develocity as a standalone application or in a Kubernetes cluster. And the difference here is Develocity doesn't push anything. Instead, the reporting kit pulls the data from Develocity. It does so with some synchronization app that regularly gets the latest builds and retries and so on. It does the bookkeeping in Postgres, and it stores the data in an S3 storage. And then there's Trino, the query engine that searches or queries Mini.io for the right data. And Trino is the same search engine that is also used under the hood by Athena. So all the queries we provide as part of these dashboards, when you run against Athena, these queries also work when you issue them directly with the reporting kit. Right? It's the same underlying technology. There's some edge cases where AWS added some convenience to the SQL language, but we're trying to avoid those so that the same query is pretty much copy-paste here and it still works. It also ships with a Grafana instance and the same dashboards that I just mentioned before. So you install this, you open Grafana. Basically, all you have to configure is where is my server, what is my access key, and you can instantly start exploring your data. And that ultimately is the goal. Right? There's all this information available in that data. We just need to surface it, and we want you to be able to explore it and draw conclusions as quickly as possible without dealing with any technical setup and intricacies. This scales really well because you can, if you install this in a Kubernetes cluster, you can run multiple nodes with Trino compute nodes, and then they distribute the work, and it scales them very well with the number of workers you run. Okay, so some people might say, well, but I don't want to have dashboards. I want something more, I don't know, I just want a different format. I want to give it to my boss. I want to add maybe some text or... So you can connect different reporting tools. Many have an Athena connector. For example, Tableau you could use and just use the Athena connector, and then you can do whatever you want to do in Tableau to surface the data. Or another approach that I think is quite compelling is to use Jupyter Notebooks. They also have a connector right into Athena where you can combine text with charts and tables and create reports, for example, as HTML reports. And you can even automate that. And on a weekly basis, you create a report that is automatically sent to your boss with some key metrics, right? Or it's sent, again, based on some thresholds when something goes wrong or however you want to work with this. But this is another format that might be quite compelling to work with that data. Okay. And so now I'd like to just round off this little journey with some use cases from the real world where we saw how valuable it was to have these cross-build insights. Because many of our customers, they don't just have one project. They have multiple projects. And when you have multiple projects, the question becomes, where do I invest my time? Where do I have the biggest impact when I give it my time? And typically, you have more things you can fix than you have time. So you have to make priorities. And you want to do them where you have the most impact. So one case we had is we looked at this data, not just this chart, right? There are tables that come with it that group build time, so build volume, by project. And some project was very high. It was also very high on the board where you see build time of failed builds. And it turned out that this project was really kind of clogging the whole CI queue, but it was not an active project. It just had some scheduling in place in CI that would run it more than once a day. So then that whole long build ran, it failed. And while that happened, of course, it took some resources that others couldn't build. And that happened several times a day, every day, over months. And they got to the point where CI was so queued that they set up more and more agents to compensate for that problem. But they never got to the bottom of what was actually causing this. They had some suspicion, but not more. But here it was evident, like you saw it right away. Also, what we don't currently have, but Hans mentioned yesterday as well, is to have similar insights for NPM and Python. So on your board, not only will you see the Gradle and the Maven and the SPT and Bazel builds, you will also see the NPM and Python builds to get a more comprehensive view of your entire developer toolchain. On the second use case I want to show is, and there Develocity did not fix the problem, right? But it surfaced it. This was a project that they have about 1,000 engineers. They run a lot of builds. And within a window of 7 days, they have a wall clock download time of 211 days. So that is not, dependency download happens a lot in parallel, the resolution, right? So we're mapping that to wall clock time. So how does it affect you in your wait time? And it adds up to about 210 days in 7 days. So very substantial. Also, a lot of data is downloaded, which is a really big load, it's a big load on their network, making everything shaky. Right? There's so much that they're downloading all the time. Right? So, but they knew about that this is problematic. They just didn't know the extent. They just saw some builds failing more often than they expected to. They heard complaints about other things affected by the network flakiness, but they couldn't really pinpoint it. But once they had that data available, they could actually make a case to get the time to fix it. And they could see how much there is to save. Of course, it's not going to go down to zero, but this was abnormal. And so they got the time, they invested it. We met about, I don't know if it was 4 or 6 weeks later. And then they were down to total wall clock time of 11 days. Just by fixing their proxy and their dependency server and so on. Also doing some things in the build, etc., etc. Right? And also the download size actually went from 15 to like less than 5 terabytes in 7 days. So here, having the data helped make a use case with the person deciding whether you can invest time into it or not. And it also helped surface how dramatic the impact was. And so they're saving pretty much 200 days every day now in 24-hour days, right, of build time every week. Now, almost everybody brings this up, that they suffer from the dependency download times, taking a large amount of time from their builds. And that's something we want to mitigate, and we're working on something that we hope will be ready sometimes in the first half of next year. All right, my third and last example, there was a project, they also had an unstable network. Seems to happen quite regularly at some companies. And it led to, you might not be able to read the number, but they had about 870 days of build time in a week. And half of it was build time where the build cache had an error. And if the build cache has an error, I mean, it's not the build cache that has an error, but trying to access the build cache caused some failure. Maybe the credentials were wrong, or the network was down and they couldn't reach the cache. In any case, the agent said, there's an error when I try to talk to the build cache, turns it off, and that made up half the build time. So out of 800 something days of build time every week, half of it, they did not benefit from the build cache. And they spend time optimizing their build to maximize the benefits they get from the build cache. So they were not aware of this. They had some anecdotal evidence. Yeah, once in a while a build has a build cache error, but that was pretty much it. So once they saw this, again, they also went into making their network more stable, fixing some other things as well. And then the trend, which we can also see, where the build time of builds with build cache errors really went down to, it's not zero, but it's almost, it's in the range of zero compared to where it was before. So it surfaced something they were not aware of. Once they were aware of, they saw the impact, so they could assess whether it's worth investing, and they said, yes, it is, definitely. And they were also able to measure whether the actions they took are actually successful. And they were. It took a while to roll out the changes and to get them actually in, but then they also had evidence, okay, this problem is now under control, or it's not a problem anymore. And it was all based on data. Okay, actually I have a fourth. Okay, so let me do that as well. And this comes up more than once for different reasons, but knowing, so there was a company that said, we should no longer use a certain JDK version. I think it was an Oracle version, due to some licensing that they did not have. But they were not sure if developers are still building with that version. And how can they find out when they have, I think, 2,000 or something developers, JVM developers? So by having the build scans available in their builds, also for local builds, because they instrumented the build with the plugin, they were able to see, oh, okay, we still have builds that are building with Oracle. And then they were able to follow up and get rid of these versions being used locally. They had mechanism to just take off the version from these machines, but they didn't want to do this not knowing whether people are still using it. Right? That would be very disruptive. So again, it gave them insights, and actually gave them an insight on something that was only available when you have local builds. All right. Okay. So to wrap this all up, with Develocity, you have the comprehensive build data available because we instrument the build and we go really deep into it and capture all this information. And we make it available via the tooling I showed, that you can instantly start exploring the data, and you don't need to worry about the technical setup and writing clients and so on. And that data exploration ultimately helps you improve your developer toolchain, your productivity, and to keep it up high once you're there. Thank you very much. Yeah, if you wanna know more, if you have some questions or so, also technical questions, then feel free to visit us at the booth in there. And yep, thank you. Thank you.